Dear students, I am Benuja, Assistant Professor of EC Department of Pondicherry College of Engineering. Today I am going to teach you polarization of plane waves. So, polarization is a study of time varying behavior of a field. It may be electric field or magnetic field. The polarization can be broadly categorized into two. One is linear polarization, second is elliptical or circular polarization. Linear polarization is, if we take an example, E vector is equal to AX vector into EX. If you look at the component, it will have only X component. The electric field is having only the X component. Then we can say this wave as linearly polarized in X direction. So the electric field is linearly polarized in X direction. Okay, so if you consider another example, say so assume our electric or magnetic field as AY into HY, then we can say that the magnetic field is polarized or linearly polarized in Y direction. So this is the linear polarization. So let us see the elliptical or circular polarization. So for studying about circular or elliptical, first we have to consider two waves, the superposition of two waves. The first wave is polarized in X direction. It is linearly polarized in X direction. Our second wave is linearly polarized in Y direction. Along with this, it will have a lag of 90 degree. Okay, so with this assumption, we have to start the polarization for elliptical or circular. Okay, so for this two waves, let us write the equation. That is, E of Z vector can be written as, it is the superposition of two waves. One is along X direction, AX, EX of, we can denote the first polarized wave as E1 of Z. Okay, and AY into, we can write or assume the second polarized wave as E2 of Z. Okay, so we will write the equation AX. The general form of E1 of Z is nothing but it will have some magnitude. Let us denote the magnitude as E1 naught. Okay, the suffix 1, the naught denotes the initial magnitude, E1 naught into E power minus J K Z. We'll denote the propagation constant here as K. Okay, and let the second equation be AY into E2 naught, because our second wave is, we can denote it with 2. So E2 naught into E power minus JKZ. Along with this, we need to mention the lag also. So what is the lag? Lag of 90 degrees. So we can denote it with minus J pi by 2. So pi by 2 is 90. Since we have lag, we can denote it with minus J. Okay, so this equation, let us write the instantaneous expression. So E of Z comma T. So if we write the instantaneous expression, the general formula is that we have studied previously. It is taking real of E of Z into e power j omega t. So this is the basic formula for finding the instantaneous expression, right? So let us substitute the Ez here. So it will become real of E of Z is, you can substitute the entire things. Okay, Ax E1 naught into E power minus JKZ. So for the first term, okay, look at the first term. The first term, it should be multiplied with E power j omega t. So I'll write the e power j omega t here, and I'll write the second term. Second term is ay e2 naught into e power minus j k z into e power minus j pi by 2. Along with this, again I will use the e power j omega t, because our e power j omega t is common for both the terms. Okay, now let us try to combine the j terms, e power j terms together. Okay, so real of ax vector into ei naught, e1 naught into e power. First you take the j outside and first write the positive terms, that is omega t minus kz. Okay, and the second term ay vector e2 naught into, again here we take the j common and we write the positive term first and then the negatives, that is minus kz minus pi by 2. Okay, so we know how to take the real. Usually real of any e power term means our e power j theta will be split into cos and j sine, and among this we will select only the cos term. So directly we can write our real of e power j is cos of that value. So we can write it as ax vector e1 naught into cos of that theta. Okay, the theta is omega t minus kz. Similarly, for the second term also we can write ay vector into e2 naught into cos of, we can write cos of omega t minus kz minus pi by 2. Okay, with this equation we have to check whether the polarization, in which direction the wave is polarized. In order to analyze the polarization, we set z is equal to 0 in this equation. So let us set z is equal to 0. So our expression will become e of 0 comma t, that is equal to ax vector e1 naught into, in cos term if we put 0 here, that is k is at 0, we'll get only cos omega t. So we get only cos omega t. So similarly for the second term we write, or if we substitute z is equal to 0, we get cos omega t, sorry cos, it should be cos omega t minus pi by 2 will come. Okay, so by using a trigonometric relationship, we know cos theta minus pi by 2, it is equal to sin theta. Okay, so this is one trigonometric relationship. So instead of writing this term, we can simply write it as sin omega t. Okay, so we'll write the same equation again. It is ax vector e1 naught cos omega t plus ay vector e2 naught into sin omega t. So this is our instantaneous expression at z is equal to 0. Okay, so if we compare left hand side, okay, left hand side with the right hand side, we can write like this. We can write our cos omega t as, okay, we can write like this. It is e of 0 comma t divided by this e naught, e1 naught. Okay, and similarly for the second term also we can write like this, that is our sin omega t is equal to e naught comma t divided by e2 naught. Okay, these two relationship, if we apply another one trigonometry, okay, that is cos square theta plus sin square theta is equal to 1. Okay, if you apply this relationship in these two equations, we will get cos square omega t plus sin square omega t. Okay, that is equal to That answer is 1, right? So that is equal to E vector of 0 comma t divided by E1 naught, again E of 0 comma t divided by E2 naught. Okay, the whole square. Cos square t, again sine square omega t, that is equal to 1. Okay, so this is the expression where we can decide whether the plane is circularly polarized or elliptically polarized. So here we have two cases. So case number 1, if our E1 naught is not equal to E2 naught. Okay, if these two are not equal, then we can write it as, we can say that the wave is elliptically polarized. Okay, the wave is elliptically polarized. Okay, similarly, the second case, if our E1 naught is equal to E2 naught, then we can say that the wave is circularly polarized. Okay, so these are the two cases. If we apply these two cases, we can decide whether the plane is elliptically polarized or circularly polarized. Okay, now with this assumption, let us do the further classification. That is, our circular polarized wave is again classified into right hand polarization or left hand polarization. That we are going to see it now. So in order to find that, first we must know the alpha. Alpha is nothing but the angle of polarization, that is instantaneous angle. It is having a formula. It is tan inverse of the second wave to the first wave. Okay, so the second wave, it is what? What is the second wave? Sine, right? Sine omega t, second component with the first component. Okay, so alpha is equal to tan inverse of our second component to the first component, second component to the first component. Okay, so that is equal to, so if we try to simplify this, what we get is tan inverse of, by using a trigonometry, sin theta plus by cos theta, it is tan theta. So it becomes tan omega t. Okay, tan omega t, and tan inverse into tan. Both will get cancelled and we get omega t. So our alpha is omega t. Our instantaneous angle is omega t. Okay, so with this instantaneous angle, we are going to plot the circular polarization, because with this condition is applicable for circular polarization. Let us draw the diagram of it. Okay, so first let us draw the planes, the x-axis and the z-axis. So this shows the x direction shows the x polarization, the y direction shows the y polarization. Here our assumption is the wave is circularly polarized. Okay, so in order to plot this alpha is equal to omega t, we will make a straight line, and this is the angle between the alpha, that is your omega t. Our omega means the polarization, it is flowing from x to y direction. So this is the angular frequency omega. Okay, so this is the circular polarization plot. We have plotted it using this instantaneous angle. Okay, so if you look at the equation or the diagram, both says the wave is rotating in a anti-clockwise direction. If you look at the diagram, it is rotating in the anti-clockwise direction. So this wave polarization is known as positive circular polarization or otherwise called as right hand polarization. Okay, right hand polarization. Okay, so because it follows a right hand rule, because that means if the electric field is moving in this way, okay, that means if you just put your fingers, use your fingers in this way, that is our electric field is rotating in x to y direction, counterclockwise direction. Our thumb points the direction of propagation, that means it is propagating in this way. Okay, because of this it is known as right hand polarization or circular polarization. Okay, similarly the same case, if we use a lag of, sorry, if a lead of 90-degree, okay, if we use a lead of 90-degree in the same condition or same example, what we get is a negative polarization or just opposite of this diagram. So for in order to examine that, we'll again assume the same condition. Instead of lagging, that means we use minus j pi by 2. Here in next case we will assume it as plus j pi by 2 and analyze it. So let us write the second case as leads by 90-degree. Okay, so that means our second wave, first wave is polarized in x direction. It is same as previous assumption. Our second case is polarized in y direction, but with a lead of 90-degree. So we'll again write the same equations. E of z vector can be written as ax ex of z. Okay, because instead of x we'll denote it with 1 of z, again a y e 2 of z. Okay, so here also we will apply the same thing, that is instead of e1 of z you will write e1 naught into e power minus j k z, and the next case we'll write ay into e 2 naught into e power minus jk z into, with a lag we have to include this lead also, plus j pi by 2. Okay, so with this we'll try to find the instantaneous expression. It is very simple, taking real of this entire term. Okay, taking real of e of z into e power j omega t. The step is very similar to the previous only, so you can do it by yourself. uh, E of z is equal to ax e1 naught into e power j k z, and we can multiply it with this term, that is e power j omega t, because it is common for both the terms. Okay, plus ay into e2 naught e power minus jk z e power j pi by 2 into e power j omega t. Okay, so this same equation will combine the e power j terms together. So our real of ax, it should be ax vector into e1 naught. You can take the j common and omega t minus kz. Okay, similarly for the second case, second term also, it should be not into e power j, and we have to start it from the positive term. So omega t minus kz. Okay, if I put plus pi by 2. Okay, so the same equation, just apply the real or pick the real alone. So what will happen, you can take the remaining things, ax e1 naught into e power j. So here we can say only the cos term, cos of omega t minus kz. Okay, and then plus ay e2 naught into cos of omega t minus kz plus pi by 2. Okay, so here for applying the boundary conditions, so just look back the procedures. After instantaneous expression, we substitute z is equal to 0 in order to analyze the wave direction. Okay, so here also we will substitute z is equal to 0. So put z is equal to 0 in the above equation. Our equation then becomes E vector of 0 comma t, that is equal to ax vector E1 naught into cos of, if it is 0, then we'll, what will be the remaining one? It will be omega t alone. Okay, then ay vector E2 naught into cos of omega t plus pi by 2. Okay, so we have a relation where we can use a trigonometry that cos of omega t, or we can simply give a common formula, cos theta plus pi by 2. It is nothing but minus sin theta. Okay, so we can apply the formula here. So in the next line we can write it as ax vector E1 naught cos omega t plus ay. So ay vector E2 naught, and instead of this term we can write it as minus sin theta. Okay, sorry, instead of theta it should be omega t. Yes, instead of theta we have omega t. Okay, so this is the instantaneous expression at z is equal to 0. So if we plot the same equation, we get the instantaneous angle as minus omega t. Okay, previously we got plus omega t. Because of that only we have defined it as positive circular polarization, but here we get minus omega t. So because of this, this wave is negatively polarized, negative circular polarized. Circularly polarized. Okay, or we can say it as left hand polarization. Left hand polarized. Because of that we call it as negatively circularly polarized. Thank you, students.